So depends on who you had last year, how much emphasis was put on this. But completing the square is a process that is expected at this point, that we would be able to do this in order to put the definition form of the equation into the standard form of the equation. You could get away without doing it, but you won't get away without doing it somewhere in this class. Especially by chapter 10, we're completing the square all the time. So I'm going to review what we mean by completing the square. These are not examples from the book or anything. It's just, let's review what we mean by completing the square. And if you never had it, okay, then just pay attention. I'm teaching it, okay? So completing the square. If you're solving an equation and you want to complete the square to solve the equation, the general process was like this, right? You would say x squared plus 8x, and you would leave a space for a third term, and then you would move the 11 to the other side. Okay, what we need to do is we need to figure out what number could we add after the 8x to create a perfect square trinomial. Okay, so here are the steps to find that number, and you'll see what I mean by perfect square trinomial at that point, right? Take whatever this number is here, right, the b, divide it by 2. In this case, you get 4. Okay. Square the 4. What do you get? 16. Put that number in there. Plus 16. The number that you add there will always be positive. It will never be negative. Because you square a positive or square a negative, you always get positive. Okay. Now, we cannot just add 16 to one side of the equation, because now it's not the same equation. So what do we do to balance what we just did? Add 16 to the other side, right? So this is, okay, we added 16, and now we have the same equation. Now, factor this. What two numbers, their product is 16 and their sum is 8? X plus 4 times x plus 4, right? So this factors as x plus 4 squared. That's what we mean by a perfect square trinomial. We added just the right number that we would be able to have some linear factor being squared in parentheses. So this is the perfect square trinomial, and then it simplifies by factoring it like that. Okay, now, notice how this is different when we're dealing with the functions that we're dealing with now. Because now it's not the quadratic equals 0. It's the f of x equals a quadratic. So it's generally this, it's very similar. F of x equals, and I'm going to go like this. X squared plus 8x. I'll leave myself a space, and I'll put the plus 11 after. Okay? I will go through the steps of finding what number do I add in that third position, exactly like I did here. So what number am I going to add? 16, right? All the numbers are the same, so we're still going to add 16, right? But if I add 16 here, I cannot add 16 on the other side because that's solved for the f of x. So how else can I compensate for having added 16 to that side in the parentheses? Subtract 16 at the end of that side. So subtract 16. So it's a slightly different process because we're dealing with a function that's solved for the f of x, right? We can't add 16 to both sides. If we add it in one spot, we take it away somewhere else. Still in balance. So here's my f of x equals x plus 4 squared minus 5. So by completing the square, we put it into the the standard form. So you could think of this again as a transformation. This is the common function that's been shifted 4 left and 5 down, or you could think of it as This is the standard form, which means these are the coordinates of the vertex, which are HK is -4, -5. Remember, the formula is x minus h in it. So if it says x plus 4, that's like x minus -4. I mean, you know that this is a shift to the left. That means x is going to be negative. And does it open up or down? Yeah. Since this is a positive number, right, +1, it opens up.